3x plus 2 times x minus 1 equals 0. We want to solve. Okay, so what I need to figure out is when is x minus 1 0, because 0 times anything is 0, and when is 3x plus 2 0, for the same reason, right? 0 times anything is 0. Well, I can look at this one right away, and I can see if I plug in a 1 for x, I'm going to get a 0. So there's one of my answers right there. It's going to be 1. This one may be a little bit more tricky. I need to know when 3x plus 2 is equal to 0. Okay, well, I can solve that without too much trouble, right? I can subtract 2 from both sides. I'll get 3x is the same as negative 2. Divide by 3 both sides, and what I end up with is x is equal to negative 2/3. So there's my other answer. When I plug in a negative 2/3, these are going to be my x's. 1, negative 2 over 3. Okay, number 2 is the same deal, except I just have 3 expressions, these 3 binomials, and I just need to do the same thing for each one. So like a plus 5, what would make that 0? Well, a negative 5. So there's one of my answers. A is going to be negative 5. Moving on to the next one, a minus 2. If I plug in a 2, I'll get a 0. So there we go. And then I could do the same thing for this one that I did for this expression up here. Set 2a plus 1 equal to 0. Solve that. Shouldn't take you too long. You would get negative 1/2. I don't want to spend too much time on this problem because I think most of you can do that. Okay, solve by factoring. So here's the key. If they tell me that I'm solving by factoring, that's a hint that I am going to be able to factor these things. Okay, so we need to dig deep and remember, okay, what do you do to factor? I need two numbers, so when I multiply them together, give me minus 35. When I add them together, give me minus 2. And here's an important factor. The leading coefficient of this quadratic equation here is 1. And that's going to make it easier. Like, so pay attention to that leading coefficient when it is 1, because it eliminates some extra work that you might have to do. Okay. So I'm looking at this, I'm thinking, okay, two numbers. Let's think about negative 7 and 5. If I multiply them, I get minus 35. I add them, I get minus 2. So there we go. So I can factor this, and I can just rewrite it now as y minus 7 times y plus 5 equals 0. And that's it. Like, and now all I have to do, I have this further step that's like, okay, well, when is that going to go to 0? And that's when y is 7. Okay, so there's one of my answers. And then when is y plus 5 0? Oh, well, that's when y is negative 5. Okay, so there we go. We're done. This one here, there's a little bit of an extra first step because I can factor out a z, right? All of these have z in common. So I can start by factoring out a z, and I'll get z squared plus 8z minus 9 equals 0. Now, this means this problem here is going to have 3 answers, because one of the answers I can see right away is this right here. If z is 0, this z on the outside, the whole thing goes to 0. So that has to be one of the answers right there. So z is going to be 0. Okay, now I'm just going to, I can kind of forget about z now and just focus on this. Again, what are two numbers? So when I multiply them together, give me minus 9. When I add them together, give me a positive 8. Now, that's kind of interesting. Okay, so we got a minus 9, right? A positive 8. That looks like it's going to be 9 and minus 1. Right? So if I factor that, it would just be z plus 9 times z minus 1 equals 0. So my z is going to be negative 9 and 1. I'm not writing these in order. Maybe I should, but if I was writing that order, I'd put the negative 9 out in front. But I'm not going to worry about that too much. Okay, when we get to 5, this is one of those situations where the leading coefficient is not 1. All right. So there's an extra step for number 5. I got to start by multiplying 6 and negative 5. We haven't done this in a while, so this is good review here. 6 times negative 5 is a minus 30, right? And I need two numbers that when I add them give me minus 13, and that's going to be minus 15 and 2. Now, here's where I have an extra step I didn't have to worry about with problem 3, or really even with problem 4. I've got to rewrite the expression now. So it's going to be 6x squared minus 15x plus 2x minus 5 is 0. And I have to do some grouping. I group the first two terms together, and I group the last two terms together. And then I ask, what's the common factor for this first expression here? 6x squared minus 15x. And I think what I can pull out of that is, well, for 6 and 15, 3. And then x squared and x, I can pull out an x. So that's going to be a 3x. And when I factor that out, I'll be left with 2x minus 5, which is what I wanted. Okay. So now what I can do is I can factor out a 2x minus 5, right? You can act as if there's a 1 here, okay? And then I can rewrite this as 2x minus 5 times 3x plus 1 equals 0. Now I actually wouldn't, when you have a leading coefficient that's not 1, I would not solve by factoring. I would use the quadratic formula, but it's still good, I guess, to know how to do it. That's how you would do it. And then I need to know, okay, well, when is 2x minus 5 equal to 0? If you set 2x minus 5 equals 0 and you solved it, you would get 5 over 2. Okay, so there's my first answer. I'm not going to show you that because hopefully you can do that. Okay, and then the same thing over here. 3x plus 1 equals 0. If I solve that, I would get negative 1/3. And so there's my second answer right there. Okay, number 6. This is one you have to look out for. They've got, this is not a quadratic, right? This is a 4th degree polynomial. But notice how the exponents, notice the pattern here. You go from y to the 4th to a y squared. Okay, usually when you see that, what that means is you can factor this just like you normally would, right? So I need two numbers that when I multiply them together give me 4. When I add them together, give me a minus 5. And it looks like that's going to be a negative 1 and a negative 4. Okay. Leading coefficient is still 1 though. So all I do is I do the same thing for 6 that I did for 3, except instead of y, I'm going to have a y squared. It's going to be y squared minus 1 times y squared minus 4 equals 0. Now here's the other thing that's tricky about this problem. You can actually factor y squared minus 1 and you can factor y squared minus 4. Those are perfect squares. Well, I should strike that. They're not perfect square. Y squared is a perfect square, 1's a perfect square, right? But when you factor that, it's going to be y plus 1 times y minus 1. And then I can do the same thing. This is factorable too. Y squared minus 4 is going to be y plus 2 times y minus 2. Alright, so I'm going to get 4 answers for this. Negative 1, 1, 2, and negative 2. Now here's the deal. If you're looking at that and say, okay, how did I get these factors? Like how did I got y squared minus 1. How did I get y plus 1 and y minus 1? Well, it's basically the same thing, right? It's like two numbers that when you multiply them together give you a minus 1. When you add them together give you 0. And that would be 1 and minus 1. But it's just if you get used to doing these, and I can see that 1's a perfect square and that 4 is a perfect square, I know that that's how it's going to be factored if there's no middle term, right? Okay, so hopefully that's not too confusing. Here we have x squared equals 27 over 4. So we're just going to take the square root. That's all we have to do. So we take the square root of x squared, we get x. Don't forget the plus or minus. Square root 27 over 4, right? So 4 is, you can take the square root of 4, that's just going to be 2. That's not too bad. So this will be plus or minus 2. Tricky thing about 27 is 27 does have a perfect square. 27 is the same as 9 times 3. 9's a perfect square, so I can take the square root of that and pull it out in front, and I'll get 3 square root 3 over 2, and there's my two answers right there. X is going to be plus or minus 3 square root 3 over 2. Okay, now I got 2z plus 1 equals 49. Same thing, take the square root of both sides, take the square root of that side, take the square root of that side. And now I've got 2z plus 1 equals plus or minus 49 is a perfect square, so that's just 7. Okay, I want to be careful at this point because I still have some work left to do. Subtract 1 from both sides, I get 2z equals negative 1 plus or minus 7. And then I'm going to divide everything by 2. Okay. So after I've done that, now I have to remember that I can simplify this, right? This is the same thing as z equals negative 1/2 plus 7 over 2. I've got a common denominator, so I can just add them across, and I'll get 6 over 2, which is 3. And then I've got to do z equals negative 1/2 minus 7 over 2, in which case I'll get a negative 8 over 2 or a negative 4. Okay, so there are my two answers right there. I'm going to get z equals negative 4 and 3. Okay, now we're down to the bottom here. Solve by completing the square. Okay, so what we want to do is rewrite it. I get b squared plus 8b plus something equals negative 15 plus something. What do I add? I just divide 8 by 2, which is 4, and square it. That's 16. This is 16. Okay, so this is now a perfect square. It's just going to be, I divide 8 by 2, and it's going to be b plus 4 squared. And it's going to equal 1. And now this problem here is just like, or very similar to this problem right here. I take the square root of both sides. I'm going to get b plus 4 equals, square root of 1 is still 1, right? So it's plus or minus 1. And so that means b is going to equal negative 4 plus or minus 1. We can simplify that. Negative 4 plus 1 is negative 3. So there's my first answer. And then negative 4 minus 1 is negative 5. So there's my second answer for that one. Okay, 10. there's some simplifying we can do right off the bat, and we should do that because it'll make the numbers nicer. We can divide everything by 2, right? We can divide all this stuff by 2. And what we would end up with is y squared minus 7y equals minus 12. And I think that's helpful because it just makes some of the math a little bit easier, right? So I'm going to rewrite this. I get y squared minus 7y. What am I going to add to that? Well, this one's going to be a little bit trickier because negative 7 divided by 2 doesn't simplify, right? So I'm just going to do that, negative 7 divided by 2, and then square it, in which case I will get 49 over 4. So that's what I got to add to the other side. I've got negative 12. And I'm going to go ahead and rewrite negative 12 as a negative 48 over 4. Because I know I'm going to have to add it to 49 over 4. Now that stuff there trips students up, right? But if I know that 4 is what I got in the denominator, I just want to multiply 12 by 4 over 4. And that's where the negative 48 over 4 comes from. Okay, so this is a perfect square now. This would be y minus 7 over 2 squared. I'm really running out of room here. I thought I would be able to do this, but it looks like maybe I won't. Equals 1 over 4, because that's negative 48 over 4 plus 49 over 4, so it's 1/4. Okay, so we take the square root of both sides and we get y minus 7 over 2 equals plus or minus 1 over 2, right? Because the square root of 1/4, if I'm taking the square root of both sides, square root of 1 is just 1, square root of 4 is 2. So now I add the 7 to the other side. I get y equals 7 over 2 plus or minus 1/2. 7 over 2 plus 1/2 is going to be 8 over 2, or 4. So there's my first answer. 7 over 2 minus 1/2 is going to be 6 over 2, and that is 3. Okay. Over here, since we've got the 2 on the left side, I'm going to go ahead and put that on the other side to start. So I'll get x squared plus 8x equals a minus 6. And then we can pretty much just go like we've been doing, right? So let's think about this. X squared plus 8x plus something equals negative 6 plus something. Okay. So negative 8 divided by 2 is 4. Squared is 16. We've seen this before. Same thing on this side. Okay. So now I've got x plus 4 squared, right? You just take the bx term and divide it by, or the b term and divide it by 2, equals 10. 10, so when we take the square root of both sides, 10 is not a perfect square. So I get x plus 4 equals plus or minus square root 10. And square root 10 can't be simplified. So my answer is just going to be x equals negative 4 plus or minus square root 10. That's what I'm going to write over here. And we can just leave the answer in that form. Just remember that that's two numbers. It's negative 4 plus square root 10, and it's negative 4 minus square root 10. Okay, 12 is like 10. We can divide everything by 2. So we would get w squared equals 6w minus 6. We can move the w over to the left side now. We get w squared minus 6w plus something is going to equal negative 6 plus something. Right? I had to move the 6w over to this side because we're completing the square, and that's why I did that. Okay, negative 6 divided by 2 is negative 3. Squared is 9. So this is going to be 9. This is going to be 9. This is now a perfect square. It's just w minus 3 squared. Remember, you take v, divide it by 2, equals 3. You take the square root of both sides, and you get y minus 3 equals plus or minus square root 3. So if I just add the 3 over the other side, now I've got my answer. It's going to be w equals 3 plus or minus the square root of 3.